Okay, so yesterday we did the derivatives of the trig functions. Today we're doing the integrals or the antiderivatives. So I want you to notice, okay, bad news, you have 3 new formulas. Good news, it's not 6 formulas, it's only 3 instead of 6. The reason is because we know with the co's, there could just be a negative involved. So remember with integrating, you're going to get to pick your u and kind of do all that kind of stuff. Why would you make it more complicated if you don't have to? That's why we're only doing 3. So over here, though, I would like to remind you, or maybe you can remind me, what is the derivative of arc sine of x?
U prime.
I guess we should really be writing arc sine of u. So if you remember this. Yeah, u prime, or I'm going to go ahead in this case write it as du.
Over root 1 minus x squared.
Good. So I want you to notice the similarities. I guess I should put, oh, that's u. That should be a u as well. There we go. I want you to notice the similarities and the differences here. So if I'm taking derivative, yeah, this is u, that's u over a. Okay, so we have this idea of a. I'll talk about that in a minute. And instead of 1, there's an a squared, but it's very, very similar. Okay, what was the derivative of arctan of u? Du over what? 1 plus u squared. So again, you can notice this is just a squared plus u squared. And yeah, there's some stuff over here. We'll get to that. All right, and then the derivative of arc secant. This is probably one you know least. You had the absolute value of u, and then here you had x squared, or u squared, sorry, minus 1, correct? Is that what it says on your paper? All right, so then that's where these come from, okay? So a couple things to note. A is always a number. It is always a number. U, however, is always a function of x. It could be x exactly, it could be 2x, it could be whatever, okay? It's a function of x. But a is always a number. So if you, one of the things we're going to be looking for when we do these problems is we're going to try to identify right off the bat which one of these it is, okay? So looking at number 1, I have square root, I have a number minus a function of x squared. Which one of these am I going to use?
Arc sine.
What does the rest of you think? Arc sine? It's not arctangent, because that has a plus and no square root. And then the bigger thing here besides this u in front is that the x thing should come first, okay? So we're probably going to use arc sine, and we are in this case, but it's good to just kind of have an idea. All right, the next thing we're going to do is we're going to assign a, u, and du. This is u substitution, but it's going to be a little bit different than the way we did it before. It's actually going to be more straightforward, okay? Because we're going to be looking at these formulas, this one, really, right now, and we're going to say, oh, here's an a squared, so 4, so what must 2 be?
2.
2, right? All right, so make sure you square root that number. All right, in place of u squared, there's an x squared. So what would u equal? X. Okay, we like it when u equals x. It means that it's going to be more, it's going to be simpler than maybe it could be. All right, and that makes du equal to dx. All right, what we're going to do now is we're going to do the substitution in. So in place of dx, I'm going to write du. In place of 4, I'm going to write a squared. And then in place of x, I'm going to write u squared. And you're going to make sure that it looks exactly like the left part of that formula. If it doesn't look like that, then you messed up and you need to go back and check. So it does. So now I can say that this equals arc sine u over a plus c. And then my final answer would be arc sine, and we get to substitute back in x over 2 plus c. And that's really how these problems work out. Again, if you know the formula, it's really not that hard. It takes a while to learn the formulas. So the nice thing is you're going to be writing them down every time. You're going to write it down just like this. is going to help you remember.
So do you have to go through like where you write it out as du over?
I'm going to say yes, because they're going to get harder. And if doing whatever you set up here, if it doesn't look exactly like the left, then you messed up and it's a good built-in check. And so I'm going to say yes, you do need to do this. So looking at problem 2, okay, again, try to identify which one you think it's going to be. Which one? Arctan, I agree. This has a plus, there's no square root. All right, so then we're going to go ahead and assign the a. You might think, oh, a is 2, but remember a squared is 2. So what's just a? Square root of 2. Okay, in this case, u is not just x, it's 3x. Because u squared is 9x squared, so u would just be 3x. So what's du? 3 dx. And we're going to do just like how we did before. We're going to take that 3, we're going to divide it over, and it's going to go out in front. Okay, just like how we did before. So when I rewrite this, the 1/3 is going to go out in front. We're going to write du. We're going to write a squared plus u squared. And I'm doing that because I'm just double checking, making sure that I did this right. And with these two, that may seem like you don't need to do it. But as you guys well know, it's going to get more complicated. So I want to give you a strategy that will work every time. So since this now looks exactly like the left side of the arctan formula, then, okay, I'm going to go 1/3 times. And I'm going to write all of this. Okay, 1 over a arctan u over a plus c. Don't try to go straight from here into plugging back in. I mean, I'm telling you, that is where students are going to, that's where they make mistakes. Just trying to do too much. All right. Now we can plug in, though. Square root of 2, 1 over square root of 2. Arctan, u was 3x, and a was square root of 2. And if you wanted to clean up this first term, you could. You could also just leave it the way it is. Okay, I would call both of these pretty basic problems. They're pretty straightforward. 2 had a number, but still, they're pretty straightforward. Okay, the next couple I do are going to be a little bit more difficult. So before I move on, are there any questions? Okay, so first glance at 3, which one do you think it is? Arcsine, arctan, arcsecant? Okay, which one are we all sure it's not? It can't be arctan, right? There's a square root and all that. Some of you said arcsine, some of you said arcsecant. So we're going to see who's right. Because there's a kind of a play for either one. They both seem is like maybe a mixture, but it's going to work out here. So we're still just going to go ahead and do the a, u, and du. All right, so our a, then, remember, is the square root of the number. So a here is 1. What's u? If there should be a u squared in place of the e to the 2x. And I can even write this over here. If u squared equals e to the 2x, what's just u? E to the x. Look, because e to the x squared, power to a power multiply the powers. All right, then what would du be? E to the x, dx. This is new. We have not seen this before. Okay, so I'm going to divide this over. So it's going to be, and I'm just writing it below because I'm running out of room. I didn't leave enough space. So I divided it over. We haven't done that before. We've only done this with numbers. Now I have an x and a u on the same line, and I've told y'all that that's not a good way to work these problems. So what can I replace this e to the x with? Yeah, look, u is e to the x. So 1 over u du that's what I'm going to replace dx with. Okay, so when I go to the problem, all right, in place of dx, now I'm going to write this way for a reason and then we'll change it. But in place of dx, I'm going to write 1 over u du. And then down here, e to the 2x, remember that was u squared minus a squared. Okay, does arcsine have a 1 over u in it? Does arcsecant? Yeah, it actually has the u down here in the denominator, but it's the same thing. A u in the denominator is the same as 1 over u. So this really is the arcsecant. So we're going to go ahead and write it. 1 over a arcsecant absolute value of u over a plus c. And then we rewrite it again. 1 over 1 arcsecant e to the x over 1 plus c. And sure, you don't need the ones there. Probably if this was multiple choice, the answer would look like this. They would even probably drop the absolute value bars. Why can you do this? E to the x is always positive. So you don't really need the absolute value bars, but if you have them there, it would not be wrong. So either one of these are right. Don't simplify if you're not sure. Okay, I really only say these things so it doesn't throw you off during multiple choice. So you don't think, oh, that's wrong because they left off the absolute value bars. Okay, so that one was a little bit harder. It wasn't too bad. All right, now we look at number 4. So I want to ask you, out of 1, 2, and 3, which one does number 4 look like the most?
Arcsine.
Yeah, it looks like 1 arcsine. What's the problem? You have an extra x on top. So either this is a really, really hard TOCO problem, or there's something that we could do in the beginning that would make it easier to work with.
Move the x down, make it secant.
Well, actually what I'm going to do here is I'm going to break this up into 2 problems. I'm going to break this up into 2 problems. All right, now you may be thinking, why isn't the dx on top? Well, you could put it on top. There's no problem with that. All right. Which piece, the left or the right, which one is going to be my arcsine piece?
Right.
How do you know?
There's no x on top.
There's no x. There's a 2, but what can I do with that 2?
Move it up.
I'm going to move it off to the side. Okay, so when I'm looking at this, 9 minus x squared, okay, I'm going to go ahead and say, okay, a, and I'm going to go into the second piece first, then I'll come back to the first one, okay? So what's a?
3.
3. U is x. That makes du dx. So I end up having du over square root a squared minus u squared. This makes this plus 2 times arcsine u over a, which is the same as saying 2 arcsine u, which is x, over a, which is 3. And I'll just put the plus c down there. I ran out of room. Okay, so that's that piece. So we broke it up into 2 pieces, and the second piece was the new stuff. That means, that implies that the first piece actually is old. So let's just assume that it is old and that we know how to do this. What would you let u equal if this had been on your last test? You would have let u be 9 minus x squared, and that would have made du negative 2x dx, which we've moved that over. So that would be negative 1/2 integral And since 9 minus x squared is the u, and the u is in the denominator, that would actually be u to the negative 1/2 du, right? I want you to notice here that this x and this dx are right here. This is why I used this. So then, to keep on integrating, I would add 1 to the power. Okay, so this makes it negative 9 minus x squared to the 1/2. And then there's your answer right there. So that's a little bit more work. So my question is, how are you going to know to do this? How are you going to know to split this up into 2 pieces? When you have an x on top, a binomial, and the x term is going to be probably like what we've already done, and the number term, well, the number outside that's going to be...
There's also a monomial.
Yeah. Well, this is more complicated than a binomial and monomial. But, yeah, I mean, I couldn't have simplified or anything. So, I want you to turn over, and let's look at number 5 now. This is gonna... Well, let me ask you. Which one do you foresee us using? Arc Sine and Arc Secant? Tan, because the denominator is plus, it doesn't have a square root.
On problems like number 2, how will you know that it's not tan other than like a natural log?
This is a great question. So the question is, how do I know this is not natural log? If the derivative of the denominator is in the numerator, or if there had been an x in the numerator, then that would be a natural log problem. And we're going to see that happen in a minute. That's a great question. So looking at this, I could split it up into 2 pieces. All right? And then the second piece with the negative 2, okay, that would be an arctan, but then I'm still going to have an issue with the first piece. So I want you to notice here that the degree on top is bigger than the degree on bottom. What algebraic thing did we do for problems like this before we even integrated? We divided. Everyone's favorite, long division. I will tell you at this point, my second period looked like they were going to cry or quit. My third period, it looked like they were going to like hurt me by the time this came up. I can't tell it by y'all. All right, so let's do this. So x squared, and I'm going to put in a 0x plus 4. And here I'm going to do 3x cubed. There's no x squared. There's no x. I'm going to do it like that. I need to divide. You do this when your numerator degree is higher than your denominator and it's not obvious. Obviously something else. So to do the long division, x squared goes into 3x cubed. How many times? 3x. 3x times x squared is 3x cubed. 3x times 0x is 0x squared. 3x times 4 is 12x. Divide, multiply, now we subtract. Okay, we know the first term is going to cancel. If the second term cancels, that's going to cut down. And you bring down the minus 2, and I can't go any further, so this is my remainder. Okay, so essentially this is what I have now. I have 3x plus negative 12x minus 2 all over x squared plus 4. Okay, ignoring the 3x for a minute, look at this part. This is just like the one we worked. So I'm actually going to break this up into how many integrals? 3. I'm going to have integral 3x dx, which is going to be really easy to integrate. Okay, then I'm going to have the negative 12x over x squared plus 4, which is probably going to be just a regular u substitution, maybe a natural log, who knows. Excuse me. And then the last one, since there's a number here, this is going to be the one that's probably going to be the arctan. And I'm just going to have to play it out to see. I will tell you, this is a really lengthy problem. I like this problem because it reviews every type of thing that can happen, but this is unlikely to be, you know, a quiz or even a test question, okay? So what's the antiderivative of 3x?
2.
3 halves x squared. I'm actually going to color code these next two pieces. And we're just going to kind of do the work, and then at the end we'll write our final answer. So on this, I know that I'm going to want to put the negative 12 in front. Okay? We're not going to do number 6, so I'll go here. So for that one, my u would just be the denominator, because my du would be 2x dx. And as long as this x dx is on the top, which it is, I'm good to go. So remember, I moved the negative 12 out. This ends up becoming, I really should have, not written that. All right, so I'm going to put the 1/2. And this is 1 over u du. So that ends up going to be negative 6 natural log of u, which is negative 6 natural log of x squared plus 4. All right. Now for the last piece. This is the new part. So the first thing, though, you're going to do is move the negative 2 out. Okay, so I'm going to come over here again. What's my a in this problem? 2. U, at least here, is x, and du is dx, so at least catch a break there. So this is going to be du over u squared plus a squared, which is 1 over a, see how small I can write this, arctan u over a. Well, in this problem, 1 over a, that's 1/2. Okay, that's going to cancel there. Arctan, tiny arctan. U is x, a is 2. So when I put it all together, bring it all down here. 3 halves x squared minus 6 natural log x squared plus 4 minus arctan x over 2 plus c. And we pat ourselves on the back. It really wouldn't be bonus, but this is too long. So it wouldn't be this. Yeah. I mean, like, without doing the long division, it would be here. Or maybe you do the long division, but then it would just be one easy piece and one arctan piece. It wouldn't be everything in one.
Did you add a bonus question that was like that?
No, because it's not really hard. It's just long. All right, let's do one more, number 7, and we're going to call it quits. We're not going to do number 8. All right, number 6, by the way, was similar to the one we just did. It's long division, and you go from there, okay? So on number 7, this is trig. But, let's see, does it fit the model of the integrals that we just learned?
Looks like the tangent.
It kind of looks like tangent, okay? And I'm going to write that down here. Kind of looks like arctan. I'm going to put a parenthesis. If this was, what would a equal? Remember, a is the number. U would be sine x. Du would be cosine x. dx. Which works. This is how, I mean, you want to know how do you know, you do whatever you do until it works. Okay? So when I rewrite this, I can, on the denominator, I have my a squared plus u squared, which is what I was hoping. But and I have a 3 here, I'll move that to the front. But this right here, cosine x dx, that was all part of my du. So then we're going to go 1 over a, arctan u over a plus c. And the more you write this down, this is going to be a way for you to remember these formulas. 1 over 1, hello. Arctan sine x over 1 plus c. Probably, to clean it up just a little bit, it's going to be arctan, and then this would be in parentheses. And, these, I haven't put bounds on any of these, but you can evaluate these at bounds, just like anything else. All right, but you're not going to have to worry about that. So I want you to just look at your homework and cross off number 19. I'm not going to do that type of problem. And so if you look at this homework, you can tell that none of these are as complicated as that one that I did.
Yeah.
I'm not going to say, though, you're not going to have to do long division. You are on one of these, at least. And so if you think about it this way on the quiz, there's going to be some that are just really basic. Some where you have a number, okay? Maybe one where you have to do long division or has an e to the x, but they're going to be doable problems. I don't want you just to focus on the ones that are the hardest ones.
Is number 7 for 7